I think next we have Niels up and running to talk about doing a SDK only machine learning sample that he's been working on.
Yeah, thanks, George. Hi, everyone. My name is Niels. I'm a new-ish person in the Flyte and Union AI team. And today I'll talk to you a little bit about a little project that I've been working on. But first, let me make sure my screen sharing is working. There you go. Does everyone see some slide decks with a title on it?
You see them, Neil? Yes.
Okay. All right. Present. Cool. So I'll kind of briefly go over this project, and I guess to preface this, I think the thing I'll be focusing on the presentation today is more of like the Flyte system and like the machine learning system more broadly, and I won't focus too much on like the model details because that's, to be honest, a little bit prototypey and probably not the best model formulation or anything like that. So yes, I'll talk to you about building an online learning weather forecasting app with Flyte and Streamlit. So a little outline of this talk, just give you a little bit of the goals and the background and motivation behind building this weather forecasting app. Then I'll go into how it's made. I'll show you a little bit of a demo and then some potential future work that I might get into. So first, I guess my background is more in the data science and machine learning side, so I'm not super into infrastructure stuff, but in previous jobs, I've kind of had to dabble in it and kind of get familiar with that stuff. But yeah, my bread and butter has really been getting data from non-traditional, like benchmark data sources, training models for business use cases. So really the goal of this, the overall project is we've kind of dubbed as Flytelab. And so you can find the projects, of which there are only one right now, but it's supposed to be a repository of non-trivial data engineering or machine learning applications that showcase Flyte's unique capabilities. So what does that mean? These are like sort of rough guidelines of how I'm thinking about these projects. So in terms of data, I can't just call package.load data MNIST or download like a pandas data frame from an S3 file. And it's all ready to go, ready to model. So those kinds of things are good for tutorials and kind of getting your hands into Flyte and get a sense of how it works. But for this specific suite of projects, I kind of wanted to go a little bit deeper and see and kind of test the limits of Flyte as a platform in terms of like certain project-specific requirements. So I'll get into that with respect to the weather forecasting app. The second one is sort of on the modeling side, biasing towards atypical training regimes. So like example, non-batch and non-tabular. So batch is like everything the model sees all of the data, the entire data set, and might even go through multiple epochs or multiple passes through that data set. Another one is like non-tabular, so text, image, things that don't come neatly in a nice table for you to model already. And the last one is in terms of use case, it has to have at least some kind of plausible real world utility. So I mean, I guess you can think of all sorts of use cases that are sort of like not that useful maybe, but so like really like the main prompt here is to try to come up with prototypes that you can kind of squint and see like a real world application. But caveat, none of what I'll show you is like ready for production or anything. So you still want to go to your weather app to get the forecasts. So for this particular project, the goal is to fetch data from a source that involves non-trivial data processing. So as I said earlier, like it's not just download data set and then you have your target column and then your feature columns and all that stuff. So here we're using the NOAA, I forget what it stands for, NOAA.gov API for grabbing the weather data. And that's just a generic API, and you can get weather data from the past couple of years all around the world with this one data set that I found on there. And it has there's no special thing that's for machine learning specifically. So you have to kind of think about how to shape that data. The second part is to implement an online learning system producing forecasts for a specific geographic location. So that's the second bit. The third one is to expose the forecasts in a user-friendly UI. So someone who doesn't know about Flyte can just go to some kind of website and see what the forecasts look like. So what's online learning? I hinted at it before, but if you contrast it with offline learning, you have access to the entire data set, potentially multiple passes through the data. Whereas with online learning, it's a setting where the data becomes available sequentially over time, and somehow you require the model to be updated because the data is kind of like quite dynamic and you can't rely on last year's data to make accurate predictions for tomorrow. So just further justifications, right? So again, this is like, I don't want to just do online learning for online learning's sake, to pick an actual application where it's appropriate. So if you think about weather forecasting, right, it's not static. That data is generated as a function of time. You can't assume IID data, independently and identically distributed data. So you can't just shuffle the data around, right? So it's like today's temperature depends on yesterday's, which depend on the previous days. And so there's some dependency there where you can't just assume independently drawn data samples. And then finally, your model needs to be up to date as up to date as possible due to the dynamic nature of the data. So a lot of time series stuff will apply to this. So like weather, stock prices, things like that, purchasing behavior. And so the model prototype I'll be referring to when you see the word model in a bunch of the next subsequent slides is super kind of silly. It's like the really toy problem at this point. But so the target that we're trying to predict is the mean daily temperature in the future. And the inputs are just the past week's mean daily temperatures. Right, so you can think, obviously, the way to make this model better is to predict more things like humidity and precipitation, but we'll set that aside for now, and I'll show you the rest of the system, and really that's the point. So how it's made, the overview, very high level, is we make a request to the NOAA.gov API. There's a workflow here for getting the training data that produces some training batches just for the past week worth of daily temperatures. There's a little other stuff here, but if people have questions, we can talk about it. That training batch is sent over to the get latest model workflow. What that does is it updates it gets the most up-to-date model and then updates it with the current data that we just got for today. And then it forecasts for, in this case, just a week's worth of forecasts of mean daily temperature, and then some metrics. Those forecasts are then read in by a Streamlit app. Streamlit it's like Jupyter notebooks, but a Python script that you can just run, and it renders like an app for you really nicely. So I'll show you what that looks like. Digging in a little bit to the data, how the data works, and I'll just talk through what this is doing. So in the get training data, we're kind of zooming into it and looking at the subtasks, but get training data itself is a dynamic workflow. And it iterates through this for loop of you specify a start date, so you can give it some prior knowledge. So if you start training the data model today, you basically you specify with the start variable here, how much prior knowledge do you want to give it? Do you want to give it, a week's worth of training before today, or 3 weeks or a month? So it iterates through here, and this is an interesting thing that I tried, and it's happily it works. But the data that Noah returns is just a CSV. It's a giant CSV for a particular kind of date range, and so you can compute beforehand whether that CSV file has all the data, or whether it's going to be updated tomorrow with some new weather data. And so here, this branching path, if the data is complete, i.e. there's going to be a new CSV file, and that the current one I'm referencing won't be updated tomorrow or the day after, you can assume that that CSV file is complete, and I'm going to just cache all of the data associated with this particular training instance. If it's not complete, I get a partial training instance, in which case I don't want to cache it, so I'll fetch it again when it's updated tomorrow. That produces a list of training instances, just batch, and that goes into the model. So that's a little fun thing that took a little bit of debugging to get to work, but I'll show you later why I did this. The model is pretty simple. This is also dynamic. I forgot to annotate this, but it just loops through the batches and updates the model for each of those days. Pretty straightforward. This is also cached, so you kind of have cached and tracked versions of all your model updates over time. And for forecasting, it's a similar thing that I'm doing. I'm just iterating from now to however many days I want to forecast for, and I do a similar thing where if I already got that training instance from the training run or a previous training run, then I don't have to recompute and get all this data. And in the case that the data is not complete, I just get a partial instance. And then I create a bunch of forecasts. And for this prototype, I made 3 launch plans, one in Atlanta, which is where I'm at, Seattle, which is where a bunch of the team is, and then Hyderabad. I think I might have missed a few team members, but this is just a fun thing to just localize all of us and get a sense of, I didn't want to do the entire world, so just had to pick some heuristic. And now I'll just want to show you a quick demo. So this is the Streamlit app that there are some issues with the Hyderabad launch plan. So right now there's just Atlanta and Seattle. But as you can see, I haven't really tuned this model very well. It's just producing kind of similar outputs for Atlanta. Seattle, at least regionally, it makes sense. So Seattle, I think the predictions are lower than than Atlanta. So Atlanta is hotter. So on average, the model is producing kind of sensical behavior, but still it's, I haven't looked at the metrics yet, but that said, this app is creating a Flyte client, and it's just reading the latest executions for each of these launch plans. So when the control plane stuff that I'm also working on is completed, the code backing this app will be a lot cleaner. It's kind of, I don't want to show it because it's kind of a rickety house. So that's it, really. So the takeaways that I got building this, I kind of started off with pure Python code, and then I wanted to see what it was like to port my Python code base over to Flyte. And it's pretty straightforward, I have to say. A few things that I learned is you can kind of make a lightweight feature store if you can make a task that's cached for one training instance. That means in this case, the input to the task that gets training instance is just date, right? So if I give that task that same date again, it's gonna just all of that computation has already been done. I don't need to ping the NOAA API anymore. And the other two are pretty intuitive. Like you can just keep track of all your model updates and model metrics over time. And actually, the way I implemented this is it like reruns the entire pipeline from the specified start date to now, which is like not very efficient, and I probably need to change that. But it is fast because I've cached all my training instances and I've cached all the model updates from the beginning. So it just kind of breezes through all of those tasks, and then just the final day for today, it'll get the training data and update the model. So that was like a nice little feature that I discovered, where I don't have to like retrain the model, even though my code wasn't as efficient as it could be. Future work, you know, again, these are kind of prototypes to just show what's capable, what Flyte is capable of. But if we were to do more work on this, produce hourly forecasts, the data is collected at the hourly level. I'm just aggregating it for the purpose of this prototype. We can additionally forecast other targets like humidity and precipitation, which would provide more information to users. Improve model accuracy, adding more features, getting a wider look back window, and then enabling user supplied geographic locations, which would be interesting, but I'm a little nervous because if like you could like put a query in and then kick off an execution and launch plan on the back end, but yeah, maybe not now, but like I feel like user accounts and stuff would be required for that. Yeah, and that's it for the talk. I'm curious if you have any questions.
It's pretty cool.
Cool.
Were there any, did you have, I know you said it wasn't that hard to migrate from your Python code to like Flyte. Were there any things that you had to like think about differently or change on the way to get them to work on Flyte?
Yeah, I think the biggest hurdle I had was changing my mindset about writing workflows, because workflows, the outputs of tasks are promises, and so you can't do anything with them except for feeding them to other tasks, which then unpacks those values. So that I was kind of thrown off a little bit by that, but once I started thinking of them in terms of like async and like whatever futures, things like that, it became a lot more intuitive for me. But because workflows look kind of like Python code, it's just a function, so you're just writing stuff. That definitely got me.
Yeah, fair enough.
Cool. Oh,
Thank you very much.
Yeah, so as you said, all of this is open source. So please go ahead, check out the repo. And if anyone is working on or can share any like showcase projects in a future demo, or can open source it, I think work with Niels to even put it in this project, in this repo, would love to. Yeah, it's pretty cool stuff. Thanks, Niels.
Yeah.
Do we still have time for another question? Cool. So
Not from you, Soren, no way.
Okay.
Sure.
So one thing I've been thinking about, because Flyte, I mean, the cool thing is that Flyte kind of captures all the historic data. So if you train models over time, of course, you'll have all the historic artifacts basically and the metrics. So have you been thinking about integration with tracking, model tracking things like TensorBoard or
Yep.
or don't know, MLflow or something like that, because I mean the data is there, right? So I mean it would be cool to actually get all the historic data to have to compare models.
Yeah, for sure. I mean, yeah, TensorBoard logs are just files, and so you can just write those out and then read them in any, with any arbitrary thing. Like weights and biases also we've looked into. I guess that would be something I would work on. Yeah, that's I would be interested in integrating with those. Yeah, I feel like TensorBoard would be a very simple thing to start with, since it's
Yeah.
file and you just
Yeah.
pump it.
Yeah.
Yeah.
Awesome, thanks.
Are you ever going to do Pandora integration and sort of scrub your input data?
That's, I mean, it exists. So Pandora is integrated with, there's a Flyte plugin for Pandora. So yeah, I guess it didn't really work well for this. I mean, I do use pandas and Pandora kind of in the back to just validate the data coming in.
Yep.
So that's, yeah, that was a thing for this project.
Thanks, Niels.